Good evening and good morning. Welcome to the OCP Tech Week 2020. So, my name is Song. I'm with the Intel. I'm the principal engineer and focusing on the AI system architecture. So, and I'm also the technical lead for the OAI high-speed workstream. So today I would like to talk about the challenges that we're going to have for the next generation OAI, right? Especially on the high-speed interconnect. So I'm going to talk about three topics here today. And the first part is that I'm going to review what we have done and the milestone that we have done right on the OAI spec in terms of the high-speed interface. And the second thing is that I'm going to talk about the what have been done in the OAM UBB 1.0 in terms of the high-speed interface spec development, right? And lastly, I'm going to talk about the next generation OAM and UBB high-speed interface challenges. Okay, first, as you can see that we started the OAM concept right a while back on the 2018, and then we started get a lot more company OEM supplier to get into the OEM form factor, and then on 2019, right, we started to see, especially on the high speed interface, right, they are moving toward the 28 gig NRZ and PCI Gen 4, and in 2020, right, and then this year we finally see that the evolve of the OAM 1.0 and 1.1 and the UBB 1.0, and we started to see a lot of the OS suppliers started to move to the 56 gig PAM4, right? And what happened next, right? So, but next year, right, as you can see, a lot of supplier, right, they're going to go with the 112 gig PAM4. And we are going to do the and also the PCI Gen 5, and this is going to be a challenge for the work stream, right? To look into the problem that we're going to see in the OEM 2.0 and also the UBB 2.0 as well. So the OAI high-speed work stream, the scope is to get do the research and do a assessment, right, on what is the right thing to do in on the PCB and the cabling, right, to support the 112 gig PAM4. So let's talk about the OAM UBB 1.0 high-speed interface spec development, right? At the time that we look into the spec, how to define the spec for the OAM and the UBB, and we look at we talk to the OEM supplier, and we look at the channel loss budget, right? And that for the scale up, so that the interface is going to be on the OEM to UBB and to the OEM is going to be a inter-module connection. And another thing that we are looking into for the scale up, right? So the scale out is going to be from the chassis to the chassis, and there are two portions that we're looking into, right? To support the passive copper cable, and this is the best that we can have in terms of the TCO power consumption, right? And if you want to go with the longer reach, and then the passive copper can support it, then you can always can go with the optical interface. And we also look into the host interface as well, right? From the OEM to the UBB and then to the HIB. So that is on the PCIe Gen 4. And and at the same time, we are also looking into the what is the right high-speed connector, right, for the OEM and the UBB, and also for the scale up and HIB, right? So those are the connectors that we base on what is the goal for the spec that we want to have, and then we talk to the vendor and get into the SI assessment, the power assessment, right? And then we come up with the spec in the of the connector spec. And at the same time, we're also looking into the PCB material as well, right? And in order to support the higher speed, we have to go with like ultra low loss material, right? Make sure that the loss budget is between the module to the module. And and at the same time, we also look into the retimer as well. So, for instance, for the scale up topology, right? And if you look at the way that the OAM partition on the UBB, right? So you have a one point that the service link is going to be over the link budget. Then we have to drop in a PHY retimer to extend the reach from the chassis to the chassis. And the same thing applied to the PCI as well. So if it depends on the different design on the HIB, it can be a co-planar or the stack design. So sometimes if you're doing the stack design, right, then you need to have the SerDes retimer, right, and the PCI retimer to make sure that you can between the PCI spec. And also we also work closely with the cable vendor as well, right? And to look into what are the gauge number, what are the LAN, and that can be supported into the onto the multi-chassis scaling. So for next generation, right? We have seen there are a few challenges, especially on the UBB and OAM, right? So as you can see in the diagram here, right? The first thing is that if you look at the OAM 0 to the OAM 6, right? So these are the longest path in the on the UBB design in order to support the topology that we want to have, right? Especially on the fully connected topology. And also the second part is the scale out, right? The scale out, if you want to scale up all the OAM to another chassis. So if you can see the first row and the second row of the OAM, right, and the link budget in between those two is going to be different. So we need to look into at at which point that we need to drop in a retimer, right, to make sure that we can extend the reach and to meet the specification. And another thing is that is for the PCI Gen 5, right? Right now we just only look at the PCI Gen 5, but we also going to look at the PCI Gen 6 as well, right? Especially if you look at the connection for the host interface board to the OAM 6, right? That is a pretty long the reach in terms of the if you have a stack UBB, UBB and HIB. So we are also looking into that and see if the retimer will be the right solution to solve the problem or not. Okay, so the way that we're doing the loss budget, we actually co-work with a lot of the OEM vendor and see what are the reach on the OEM side, and then on the UBB 1.0, that's how we come up with the spec on the UBB. So we have the loss budget for the OEM and for the UBB, and based on the 50 gig 56 gig PAM4 standard, there is a 30 dB, and that's how that we just reserve 8 dB for the OAM on the TX and the RX, and 14 dB on the UBB. So what happened is that for the next generation, right, because the loss budget is very critical for the 112 gig PAM4, and we can see that the spec itself is still going to be between 28 to 30 dB. But what happened is that the PCB material connector, right, that tends to be have more loss than the 5060 PAM4. This is something that the high speed work string is going to be looking to and work closely with the OEM supplier, right? See what we can do on the OEM TX and RX lane, right? Can we squeeze it a little bit more? And we want to see, understand what are the package, what the routing on the OEM, make sure that it doesn't go beyond that. And at the same time that we're also going to look at the UBB as well, right? What are the margin that we can get based on the latest PCB material? Okay, and at the same time, we're also going to look into the revisit the connector that we have on the OAM, UBB, and HIB 1.0. So there are a few connectors that we use on the OAI project. One of them is the mirror mesh connector to interconnect the OAM to UBB, and the other one is the UBB to the HIB, right? It's what we call XMX. And also the scale out connector which we have right now is for the QSFP DD. And also for the HIB CPU node, right? How do you connect to the CPU node? And it's going through the Gen 4 retimer card. What are the cable and cable loss and the cable spec? So for the next generation, right, we are going to revisit, see if the mirror mesh is still the right solution, right? Or maybe there is a improvement on the connector that can support 112 gig. PAM4. And but also at the same time, we're also going to look into talking to the OEM supplier, right? Is the existing 1.0 spec meet their requirement for the next generation? So this is some discussion that we're going to have in the work stream, and not just the high speed work stream, also talk to the system work stream, the power stream, right? Because the connector is very important for the power delivery as well. Yeah. So and the next thing is that we're going to look into is the UBB to HIP connector. You want to see if the same connector, right? And does it meet the PCI Gen 5 or Gen 6? And that's something that we want to make sure that when we define the OAM 2.0, it should cover 2 generations of product. And at the same time that we also following the industry standard on the especially on the QSFP-DD, and right now they are working on the QSFP-DD 800, right? This is support the 112 gig, and we are also going to look into the cable as well. And for the HIB to CPU node, right? We're going to see what is the right PCI retimer card in terms of the loss, and what is the loss budget that we're going to targeting, right, going into the HIB. So those kind of work is going to be done by the high speed work stream. So talking about the PCB material, so if you look at the 56 gig PAM4 on the UBB 1.0, we are using the ultra low loss material, and the loss budget, right, they are for the SerDes or the PCIe. Right now we are looking at 14 gigahertz. The loss per inch is like 0.88 dB. And for the next generation design, right, we are going to look into the what we call the hyper or extreme low loss material is the next generation of the PCB material. And we still right now the most of the PCB material is not available yet. It's still in like a testing phase. We're going to get a lot more information early next year, right? And we want to get into more detail on at 28 gig or 32 gig. What is the loss per inch that we can have? So I think the whole goal that we try to get is that to keep it below 1 dB. The same thing happened to the retimer and also the scale up, right? On the 56 gig PAM4, you can see there's a couple of vendors that have the retimer support in the OAI project, right? And there has an 8 or 16 lane on both sides, which has a 28 dB loss budget. And with the 28 gig gauge cable, right, we can actually extend the cable reach to 2 meter or 2.5 meter, depends on the gauge number, right? And for the next gen, it's going to be more it's going to be more of the challenges, right? And want to see if we can use the same retimer spec, right, in terms of the loss, and see if we can have the right cable, and for the passive copper cable to do to have the same spec for the OAM 1.0, or otherwise that we have to go with the low power optical transceiver. That's it for my talk today, and thank you all.
Hey Song, thank you so much for that presentation.